the process of extraction of energy is called as a turbine, and the process of adding of energy is called as a pump. So ஒரு எனர்ஜியை நம்ம ஆட் பண்ணோம் அப்படின்னா தட் இஸ் கால்ட் அஸ் அ பம்ப். அதே எனர்ஜியை இஃப் வி எக்ஸ்ட்ராக்டட் அவுட் தட் இஸ் கால்ட் அஸ் அ டர்பைன். எப்படின்னா சே ஃபார் எக்ஸாம்பிள் இமேஜின் நவ் வி ஆர் ஹேவிங் ஒரு ஹைட்ரோ டர்பைன்ஸ் இருக்கு. ஒரு ஹைட்ரோ டர்பைன்ஸ்ல ஒரு வாட்டர் ஃப்ளோ உள்ள இருப்போ தி ப்ராசஸ் ஆஃப் தி potential energy என்னவாகும் when the water is getting flowed, the potential energy is converted into kinetic energy. That kinetic energy will transform to the turbine, thereby the extraction of energy is getting out. So maybe by means of the rotational energy மூலமா we can get out the extraction of energy, and the flow is out by the means of the draft tube. So draft tube வழியா the flow is getting out. So in between the process of turbine and getting extraction of energy is getting added. Now when the same is happened in terms of pump la வந்து பாத்தீங்கன்னா again the process of fluid is flowed into the pump or the system, right? So in the systemத்துக்குள்ள போறப்போ if we are giving some an additional energy, say for example you are giving some sort of electrical power, right? So on the electrical power கொடுக்கறப்போ we are based upon the given electrical power or some sort of any kind of a mechanical power. So the pressure of the fluid which is came inside ஒரு fluid ஒரு pressureல உள்ள வர்றப்ப என்ன ஆகும் by means of this additional energy giving either terms of electrical energy or mechanical energy, இந்த பம்ப்ல கூடிய pressure வந்து பாத்தீங்கன்னா pressure energy வந்து பாத்தீங்கன்னா energy is getting added up and it gets flows out. So this is the common difference between the pump and turbine. No. So in general all those kind of turbines, it may be in terms of turbine இருக்கலாம் or terms of pumps இருக்கலாம், both the energy are commonly said as by means of the power which is given extracted out. Either maybe a pump இருந்தாலும் சரி or maybe of turbine இருந்தாலும் சரி, what they are getting the energy is called as hydraulic energy. The hydraulic energy is what is produced by water which is stored in a reservoir. As say for example if you are getting power வந்து நம்ம எடுக்கிறோம் அப்படின்னா the water is stored at very altitude level. Altitude level high altitude level the water store ஆயிருக்கும் as you know. So once it is having because of the gravitational force, so it is having or high altitude la irukradhanaala it is having the gravitational force. So the principle behind the gravitational force is that is P is equal to rho g h. That is one we have. So P is equal to rho into g into h, right? So when that is the pressure is directly proportional to height, right? அப்போ ஹைட் எந்த அளவுக்கு தி வாட்டரோட altitude increase ஆகும், the pressure will get altitude increases. So this is the main reason behind the அப்போ இந்த இடத்துல வந்துட்டு the height will be considered as the potential energy. Whenever the height is getting increased at static level or stagnant level, the potential energy will increase ஆயிட்டே இருக்கும் when the altitude increases. So when it gets flows down, so flow ஆகறப்ப என்ன ஆகும் அப்படின்னா the process of the potential energy is transformed into a kinetic energy. So the potential energy என்னவாகும் more அப்படின்னா kinetic energy convert ஆகும். After that it will be converted into a pressure energy or electrical energy. That is afterwards because of the pressure energy we will getting the extracted of the electrical energy. That is the principle behind an example of hydroelectric power plant, right? So now these are the classifications of turbine or turbo machines and எப்படி classification பண்றாங்க. So what we are studying the turbo machines is only of turbines and pumps, right? So if your civil subjects gone through GDJP, that is gas dynamics jet propulsion, the subjects which we have gone through, we have study upon compressors பத்தி படிப்போம், blowers பத்தி படிப்போம், turbo fan, turbo props, இதெல்லாம் பத்தி we have discussed generally. Right. So what we generally discuss on our subject வந்து பார்த்தீங்கன்னா what is called turbine அப்படின்னா என்ன and what is called pumps, right? So apart from this turbine and pumps, there are some other turbo machines. Compressor is also one kind of turbo machine. Blowers, so air blowers or draft ன்னு சொல்லி சொல்லுவாங்க, that is also one kind of a turbo machines. A fan, turbo fan or turbo prop, இதெல்லாமே it's one kind of where this kind of turbo fan blowers it deals with air and gas. The compressor blower fan deals with only air and gas, where the pump is deals with the process of extraction or adding up of energy through water, slurry or liquid. In terms of turbine and in terms of hydraulic, steam turbine, vapor, gas, wind turbine. So இதெல்லாமே வந்து பாத்தீங்கன்னா it deals with the process of so in the turbines they are having different types of turbines இருக்கு, right? So what we generally the classifying based upon So based upon the absorb, that is based upon energy addition or extraction. So if it is an extraction, we very well know that it is turbine. If the energy addition, it is called as a pump. So first, in absorb energy to increase fluid pressure is called as a pump. Whereas producing energy by expanding flow to lower pressures, this is called as a turbines. So and the producing this is kinetic energy மூலமா energy extract பண்ணி அதோடைய ப்ரெஷர் வந்துட்டு எக்ஸ்ட்ராக்ட் பண்ணிட்டு in terms of energy convert பண்ணிட்டு then the pressure in the fluid is reduced to lower pressure அப்படிங்கிறது வந்து this is called as a turbine. Now based upon the direction of flow. So direction of flow அப்படின்னா என்ன, there are different types of turbines இருக்கு. அப்போ the flow which is inlet, the flow which is passed to the turbine, inlet of the turbine எந்த டைரக்ஷன் உள்ள போகுதோ அதை போட்டு கிளாசிஃபிகேஷன் பண்றாங்க. That is called as axial flow. Then the second one is called as radial flow, and the third one is called as mixed flow, which involves both the axial and radial. That is tangential flow. So mixed, that is inlet வந்து பாத்தீங்கன்னா axial இருக்கும், outlet வந்து பாத்தீங்கன்னா radial இருக்கும். That is called as mixed flow, right? So based upon the type of fluid handled, so more probably like we are getting extraction of power or the producing power or adding power for both the liquids, for the fluids. So fluids in Bodinave, it involves with both the compressible and incompressible. So compressible abdina, right, and the pressure does not change, right? So on the, say for example, a particular point let me see that. So if it is incompressible fluid, now it cannot able to compress the fluid. Say for example, liquid is one kind of incompressible fluid, whereas gas in the it will be called as a compressible fluid. So the fluid which deals with the compressible fluid is called as a compressor. Compressor on the deals with the compressible fluid, whereas pump on the deals with the incompressible fluids. So as again, the based upon number of stages in the single stage, multi-stage. Now we were moving into the term called as a pump. So pump let me see in detail. So as we know that pump is the process of conversion of a mechanical energy into hydraulic energy. So it is a mechanical device which transforms energy from the external source to the liquid flowing to the conduit. So it, when உள்ள கொடுக்கக்கூடிய energy வந்து பாத்தீங்கன்னா mechanical energy இருக்கும். In general, pumps in the mechanical energy is also converted to before that it is called electrical energy. So electrical to mechanical to hydraulic. So this is the scenario. இதே வந்து பாத்தீங்கன்னா in terms of turbines this is vice versa, from hydraulic energy to mechanical energy to electrical energy. So this is vice versa. Whereas pumps வந்து பாத்தீங்கன்னா electrical energy is converted into mechanical energy. Since we have to start for the pump, we have to give input power as the electrical motor. That is a motor is driven here. So it is a electrical driven motor. So electrical energy கொடுத்தது mechanical energy கவர் பண்ண முடியும். Rotational force கிடைக்கும். But rotational force is called as a mechanical energy. So because of the rotational force, the energy is added up to the fluid that we are achieving the hydraulic energy. So in that pump classification, there are different types of classifications of pumps. So there are two general classification of pump. One is dynamic pressure pump and positive displacement pump. So the term positive displacement pump அப்படிங்கிறது வந்து பார்த்தீங்கன்னா we are changing the cross section or trapping. And let me see the in next slide. So in the classification வந்து பார்த்தீங்கன்னா there is dynamic pressure pump. அதோட sub classification வந்து பார்த்தீங்கன்னா centrifugal pump, jet pumps. So we have normally seen our வீட்டில் இருக்கக்கூடிய pumps, mostly all the pumps are classified as a centrifugal pump. Whereas the second sub classification வந்து பார்த்தீங்கன்னா positive displacement pump. Whereas the reciprocating pump, rotary pump, gear, lobe, vane, screw pump, and the screw pump வந்து பார்த்தீங்கன்னா compressor and screw compressors எல்லாம் இருக்கும். That is one kind of screw pumps and the rotary plunger pumps. These are the various classification of pumps. So where what is called as a displacement pump? For two classification நம்ம பார்த்தோம். One is called as a dynamic pressure pump and the second one is called as a positive displacement pump. The term the positive displacement அப்படின்னா என்ன அப்படின்னா where we are having ஒரு confined region குள்ள we are moving the fluid, right? Say for example, if it is a screw compressor அப்படின்னா அந்த screw compressor வந்து ஒரு cross section area, ஒரு confined zone இருக்கும். அந்த confined zone குள்ள we are pushing up the fluid, right? So thereby the pressure is getting increased. So that kind of system is called as a positive displacement pump. That is, make a fluid move by trapping the fixed amount and forcing the trapped volume is into a discharged pipe. So the trapped volume அப்படின்னா the reduced in cross section area, இங்க ஒரு இன்லெட் மெயின் ஸ்ட்ரீம் வெலாசிட்டியில ஒரு ஃப்ளூயிட் உள்ள வருதுங்கிறப்போ அதை வந்து நான் ரெடியூஸ் பண்றேன். நான் எதர் டைப்ஸ் ஆஃப் ஸ்க்ரூ டைப் பண்ணலாம், கியர் லோப், வேன், ரெசிபிரோகேட்டிங் பம்ப்ல வந்து உள்ள வந்து ஐம் ரெடியூசிங் தி வால்யூம், ரைட்? ஸோ தேர் பை இன்க்ரீசிங் ப்ரெஷர். ஸோ ஐம் ஜஸ்ட் ட்ராப்பிங் தி ஃப்ளூயிட் இன்டு எ சர்டன் கன்ஃபைன்டு ரீஜன். அப்போ அந்த கன்ஃபைன்ட் ரீஜன் இருக்கிற ப்ரெஷர் வந்து மேக்கிங் இட் டிஸ்சார்ஜ் திங். That is called as a positive displacement pump, whereas in which the volume is constant throughout. Otherwise, the output of the volume is constant through each cycle of operation. So these are some of the examples. Rotary type line, gear, screw, reciprocating type. These are the classifications of this positive displacement pump. So as you know very well, reciprocating pump having a piston and having a cylinder. So inlet section and the suction head and there is delivery head இருக்கும். ஸோ இன்லெட்ல ஃப்ளூயிட்ல உள்ள வரப்போ தட் இஸ் மூவிங் ஃப்ரம் ஐடிசி டு ஓடிசி. ஸோ இது வந்து இன்டெல் ஐடிசி டு ஓடிசி போறப்போ திஸ் ஓடிசி, ரைட்? ஸோ அவுட்டர் டெட் சென்டர் ஆர் இன்னர் டெட் சென்டர். ஸோ வென் இட் மூவ்ஸ் ஃப்ரம் ஐடிசி ஓடிடி சக்ஷன் வில் பி ஹேப்பன். திஸ் இஸ் அ நான் ரிட்டர்ன் வால்வ். ஸோ வென் இட் மூவ்ஸ் ஃப்ரம் ஓடிசி டு ஐடிசின்னு போறப்போ இது நான் ரிட்டர்ன் வால்வ் இட் வில் க்ளோஸ் ஆகும், இந்த வால்வ் ஓப்பன் ஆகும். ஸோ டிஸ்சார்ஜ் வில் பி ஹேப்பன். This is the general principle of the reciprocating pump by the rotation of this crankshaft. The canting rod. These are general principles of reciprocating pump. The next one is called as a gear pump. So gear pump. So these are the various classifications of pump. This is very easy. Constructions romba explain panna vena. This all this type of gear pumps, reciprocating pumps is one kind of a past displacement pump. ஏன் பாஸ்ட் டிஸ்பிளேஸ்மெண்ட் அப்படின்னா ஒரு ஃப்ளூயிட் இன்லெட்ல உள்ள வர்றப்ப என்ன ஆகும், இதோடைய வால்யூம் ஆஃப் ஃப்ளூயிட் தட் இஸ் தி ஏரியா ஃப்ளூயிட் வந்து நம்ம கன்ஃபைன் பண்ணிடுறோம். இந்த ரெடியூஸ்டு நம்ம கிராஸ் செக்ஷன் கன்ஃபைன் பண்ணிடுறோம். ஸோ இதன் மூலமா ப்ரெஷர் இன்க்ரீஸ் ஆகும். தேர்பை இட் கெட்ஸ் ஃப்ளோஸ் அவுட் த்ரூ ஆல் த டைப்ஸ் ஆஃப் பாஸ்ட் டிஸ்பிளேஸ்மெண்ட் பம்ப், ரைட்? ஸோ லோப் இஸ் ஆல்சோ ஹேவிங் தி சேம் பிரின்சிபல். நோ தி another set of classification pump is called as a centrifugal pump, where it is having the actuation of the centrifugal force, right? So it is a machine which converts a mechanical energy into a kinetic and pressure energy. So both the respective kinetic energy and pressure energy will be is converted by means of this centrifugal pump, right? So inlet fluid வரப்போ அதுல இருக்கக்கூடிய இந்த veins, right? So இந்த rotation of veins. So veins நீங்க போறப்போ பம்ப்ல பொறுத்த வரைக்கும் அந்த inlet velocity triangle you have to make it very very careful. அது கொஞ்சம் ஞாபகம் வச்சுக்கோங்க. So the velocity triangle is very very important. So this is what the velocity triangle for the veins for centrifugal pump. So inlet velocity illa vandu pathina what is getting inletted and what is getting outletted. So romba in depth we have to solve this kind of velocity triangles நம்ம solve பண்றதுக்கு it's not necessary now. So but try to understand what is the velocity triangle. ஒரு inletல விளையாடுறப்போ எப்படி radial inlet எப்படி போகுது, எப்படி outlet transformation நடக்குது, இத கொஞ்சம் ஞாபகம் வச்சிட்டீங்கன்னா it's very important here. So the process centrifugal pump is by means of the rotating or water வந்து பாத்தீங்கன்னா tangential direction உள்ள வரும் through the casing, right? So இந்த casingல மூலமா so the casing is called invalid casing சொல்லி சொல்லுவாங்க, diffuser or invalid casing. So the invalid casing cross section வந்து reduce ஆகும், right? So through by means of that the cross reduce ஆறப்போ the pressure is getting increased, thereby achieving the kinetic energy and pressure energy at the same time. So these are the general classifications of pumps. Right. So the next one is called as a turbine. So are you guys are following me?
Sir.
Yes.
Yes, sir.
Right. Shall I continue?
Yes, sir. Continue, sir.
Right.
Yes, sir. Continue, sir.
So far we have discussed on the concept of the pump. So pump la வந்து we have seen past displacement pumps அப்படிங்கிறது என்னன்னு பார்த்தோம். Then the second set of category is called as a centrifugal pump, and before that what is called kinetic energy and what is called pressure energy and what is called potential energy. So இந்த மூணு எனர்ஜி ரொம்ப ரொம்ப இம்பார்ட்டன்ட் அப்ப அது நல்லா ஞாபகம் வச்சுக்கோங்க. Then the second set of வந்து turbines. So turbine is the, as I said, it is the process of extraction of energy. So in the my words it is called an extraction of energy, where in pumps is an adding up of energy. So extraction to adding to there will be some differences, right? So the turbine is rotating mechanical device that extracts energy from a fluid flow and converts it into an usable work, right? we are having useful blades. So as far the classification is concerned, these turbine classification there are different types of turbine actually, right? So hydraulic turbine, gas turbine, steam turbines, and wind turbines. So there are different types of classification of turbines. What we are majorly looking into in fluid mechanics is hydraulic turbine, right? So gas turbines இருக்கு. Then apart from gas turbines வந்து turbojet இருக்கு, turbo fan, turbo prop. So இந்த மாதிரி different set of turbines நமக்கு இருக்கு. But in related to fluid mechanics, we are mostly getting to concern with the hydraulic turbines. So இப்போ இந்த hydraulic turbines வந்து பாத்தீங்கன்னா there are two general classification of these hydraulic turbines. One is an impulse turbine and the second one is called as a reaction turbine. சரிங்களா? So whereas the term impulse, and the impulse அப்படிங்கிறது வந்து it is called as a sudden force, right? So the high velocity jet of water strike ஆகிறப்போ the in a rotating blade strike ஆகிறப்போ the sudden impact, the jet ன்னு சொன்னாவே என்ன, jet of velocity ன்னு சொல்லுவோம். The word called as a jet of velocity. So jet of velocity அப்படின்னா it is having a high velocity, right? So on the high velocity fluid வந்து ஒரு blade மேல போடுறப்போ that force is called as an impulse force, impulsive force ன்னு சொல்லுவோம். So those impulsive force or high jet of velocity இருக்கக்கூடிய turbines பேர் வந்து பாத்தீங்கன்னா that is called as an impulse turbine. Whereas, right? So the reaction turbine, so the term reaction turbine it is the process of reaction. இருக்கக்கூடிய potential energy வந்து என்ன ஆகும் அப்படின்னா through from the high altitude, right? It will converted into ஒரு பென்ஸ்டாக்குள்ள வர்றப்போ it instead of impulse giving a sudden force, it will react with the turbines or the blades, right? The best example is Francis turbine, Kaplan turbine, and propeller turbine. They occur to the direction of flow. This is hydraulic action. Yes, based upon the striking of earth, it is called as an impulse reaction. And according to the direction of flow, right? So what direction the fluid flow is given feed to the turbine? Inlet flow எந்த அளவுக்கு இருக்கோ அதை பொறுத்து இந்த டைரக்ஷன்ல இருக்க பொறுத்து கிளாசிஃபிகேஷன் பண்றாங்க. ஒன்னு axial turbines and radial turbines and tangential flow turbine. So the tangential flow turbines is the flow is getting ஒரு particular directionல வந்து பாத்தீங்கன்னா ஒரு swivel மூலமா the process is called swivel. Swivel actuation மூலமா the tangential flow activate பண்ணுவாங்க. That best example is called as Pelton turbine. And the radial turbine is called as Francis turbine, and the axis turbine is Kaplan turbine, right? So let me see what is called radial, what is called axial. In terms of head, this is very important, height. So சில இடத்துக்கூடிய bridge dams வந்து பாத்தீங்கன்னா having the very high altitude, right? So for those kind of very high altitude, I am getting the maximum amount of kinetic energy. So அதன் மூலமா எனக்கு கிடைக்கக்கூடிய high impact forces கிடைக்கும். So there we are getting high impulse forces அதிகமா கிடைக்கும். So those kind of turbines is called high turbines. Best example is Pelton. ஒரு medium head, ஒரு low compared to high head turbine, ஒரு medium head இருந்ததுன்னா we are using for அந்த இடத்துல எந்த மாதிரி turbines யூஸ் பண்ணுவோம் அப்படின்னா Francis turbine யூஸ் பண்ணுவோம். இன்னும் நம்ம lower level turbines இருக்கு அப்படின்னா ஒரு medium scale dams அந்த மாதிரி டேம்ஸ்ல வந்து பாத்தீங்கன்னா we are going for the low head turbines or lakes இதுல இருந்து வரக்கூடிய எல்லாமே low head turbines. So this is an impulse turbine, what I said right now. So all the energy of water is converted into kinetic energy, right? So water in the form of jet from into a nozzle. So confined region kulla and the water flow கொடுக்கிறப்போ impact high velocity impact create ஆகும். Whereas in reaction turbine is a pressure head is converted into kinetic head and the remaining part as pressure head. So right, so the partial conversion of the pressure energy into that is the partial conversion of the pressure head into kinetic energy, right? So it will react with the turbines, right? So reaction pressure is responsible for the motion. So on the kudukuriya rotation of turbines வந்து பாத்தீங்கன்னா based upon the reaction it will happen here, right? So this is the example of this Pelton wheel. So high இந்த இதோட ஆக்சுவேஷன் பொறுத்து இதோட வெலாசிட்டி வந்துட்டு டிட்டர்மைன் பண்ணுவாங்க. So what is called as this is called as a radial flow turbine. So right, So it is along the direction. So இதோட duration பொறுத்து rotate ஆகிறப்போ this is called as an axis. இப்படி நேரா வந்தது அப்படி this is called as, if the flow is in the along the axis, that is called as an axial flow. If it is perpendicular to the axis அப்படின்னா this is called as a radial flow, right? So in the center vertical axis of the shaft க்கு எனக்கு perpendicular directionல flow inlet ஆச்சு அப்படின்னா that will be called as an radial flow. But this kind of Francis turbine is kind of a mixed flow. So இது வந்து radial inlet, axial outlet, radial inlet, axial outlet. ஸோ இதே வந்து பார்த்தீங்கன்னா ஆக்சியல் ஃப்ளோ அப்படின்னா தி வாட்டரோடைய ஃப்ளோ வந்து பார்த்தீங்கன்னா எனக்கு ஆக்சியல் டைரக்ஷனில் இருக்கும், ரைட்? ஸோ திஸ் கைண்ட் ஆஃப் ஃப்ளோ இஸ் கால்ட் அஸ் அன் பெஸ்ட் எக்ஸாம்பிள் இஸ் கால்ட் அஸ் அன் கப்லான் டர்பைன். ஸோ இந்த கப்லான் டர்பைன் ஹேவிங் இட் இஸ் suitable for low heads and adjustable blades. So right, so this is having for the turbines and pumps. So இப்போ இந்த turbines and pumpsல what we generally look upon is pump அப்படிங்கிறது வந்து பார்த்தீங்கன்னா அதோட ரெஸ்பெக்டிவ் கிளாசிஃபிகேஷன்ஸ் பற்றி நல்லா பார்த்துக்கணும். அண்ட் சிமிலர்லி டர்பைன்ஸ் இஸ் ஆல்சோ வெரி இம்பார்ட்டன்ட். ஸோ ஹவு வி ட்ரா அபவுட் தி வெலாசிட்டி ட்ரையாங்கிள்ஸ் இது எப்படி ட்ரா பண்ணுவோம். சிமிலர்லி ஃபார் தி பம்ப்ஸ் அண்ட் டர்பைன்ஸ்க்கு வந்து பார்த்தீங்கன்னா டர்பைன்ஸ் இஸ் ஆல்சோ ஹேவிங் தி வெலாசிட்டி ட்ரையாங்கிள், ரைட்? ஸோ இது நெக்ஸ்ட் அனதர் இம்பார்ட்டன்ட் திங் என்னன்னா வைல் கோ ஃபார் தி டர்பைன்ஸ். ஸோ நீங்கள் டர்பைன்ஸ் போகிறப்போ வாட் இஸ் கால்ட் கிராஸ் ஹெட், தெர் ஆர் டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் பேராமீட்டர்ஸ் இருக்கு. Say for example the gross head HG அப்படினா என்ன, let it take it. So gross head HG அப்படினா என்ன, right? So the next one the type of net head, what is called net head. So and what is called efficiency. So another important is efficiency of turbine. So இதெல்லாம் கொஞ்சம் நீங்க நிறைய பார்க்க வேண்டியது இருக்கு. So what is called as hydraulic efficiency அப்படினா என்ன, mechanical efficiency, and what is called as volumetric efficiency. Volumetric efficiency அப்படினா என்ன, right? And what is called overall efficiency. So all those parameters I'm just writing down what is called overall efficiency and what is called in hydraulic volumetric efficiency, right? And what is called mechanical efficiency, what is called hydraulic efficiency. So இது எல்லாத்தையும் நீங்க we have to study upon. Overall efficiency அப்படினா என்ன, what is the formula begin there. Say for example if it is a hydraulic efficiency, or hydraulic efficiency அப்படினா the respective formula will be the RP by WP ன்னு சொல்லுவாங்க. That is runner power divided by water power, right? So now what is called runner power அப்படினா என்ன, and what is called water power. So all the things we have to look into concern. So இந்த நாலு டைப்ஸ் ஆஃப் எஃபிஷியன்சி வந்து கம்பல்சரி ஞாபகம் வச்சிருக்கணும். Overall efficiency, volumetric efficiency, mechanical efficiency, and hydraulic efficiency. So these are the various types of efficiency. And classifications as you know very well. So Pelton turbine, all those kind of turbines you know. And of course the velocity triangle and work done, right? So the compulsory what will the velocity triangle. So if it is in Pelton turbine abdina, the velocity triangle will be here. So what is the output flow velocity and radial velocity? You have to draw the respective velocity triangles over here. So இதே பெல்டான் டர்பைன்னா இந்த இன்லெட்டுக்கு வந்து பத்தி எந்த ஒரு வெலாசிட்டி ட்ரையாங்கிள் இருக்காது. ஸோ இட் வில் பி லீனியர். இது அவுட்லெட் வந்து வெலாசிட்டி ட்ரையாங்கிள் கம்பல்சரி இருக்கும். ஐ ஜஸ்ட் டிராயிங் ஓவர் ஹியர். ஸோ இன்லெட் இது இஸ் பெல்டான் வீல் ஆர் பெல்டான் பிளேட்ஸ் இருக்கும். ஸோ இன்லெட் வெலாசிட்டி வந்து லீனியரா இருக்கும், அவுட்லெட் வந்து வெலாசிட்டி வந்து பார்த்தீங்கன்னா ட்ரையாங்கிள் ஃபார்ம்ல இருக்கும், ரைட்? இதே சிமிலர்லி ஃபார் கப்லான் டர்பைனுக்கும் அண்ட் பிரான்சிஸ் டர்பைனுக்கும் யூ ஹேவ் டு ரைட் ட்ரா த ரெஸ்பெக்டிவ் வெலாசிட்டி ட்ரையாங்கிள். ஸோ இட் மேபி இஃப் இந்த இன்டர்வியூட பார்ட் டஃப்பாக இருக்கும் அப்படின்னா they will definitely ask you to what will be the velocity triangle for Pelton wheel. So ஏன்னா இந்த Pelton wheel ஓட velocity triangle வந்து it is different from another two Francis turbine அப்புறம் turbine கம்பேர் பண்றப்போ velocity triangle டிஃபரெண்டா இருக்கும். ஏன் டிஃபரெண்டா இருக்கும் அப்படின்னா since it is a high velocity impact, இந்த Pelton wheel ஓட blade வந்து பார்த்தீங்கன்னா இட்ஸ் boat like structure னு சொல்லுவாங்க. ஸோ அப்போ இந்த inlet velocity வந்து பார்த்தீங்கன்னா இட்ஸ் linear type velocity இருக்கும். ஸோ அதனால இந்த டைப் ஆஃப் வெலாசிட்டிஸ் வந்து மோஸ்ட் ஆஃப் இன்டர்வியூஸ்ல வந்து they ask you to draw the respective velocity triangle for Pelton wheel turbine, right? So apart from these turbines, so the turbines apart from பொறுத்த வரைக்கும் as I said gas turbines இருக்கு, turbojets இருக்கு, turbo fan இருக்கு, turbo prop இருக்கு, right? So இந்த மாதிரி different types of turbines இருக்கு, but they will the fluid mechanics we won't study. That will be studied under gas dynamics and jet propulsion subjects. You look at that. what is called turbojet, what is called turbofan, and what is called turboprop, gas turbines or principles and steam turbines or principles and இதெல்லாமே we will study over that in the GDJP. Right now, next we move on to the next set of classification here. Right. So now, so far we have discussed on what is called fluids, that is what is called pumps and what is called turbine. அது நம்ம ஜெனரல் என்னன்னு பார்த்தோம். Now we are moving on to what is called kinematics of flow, right? So the term kinematics of flow அப்படின்னா என்ன, now what is called continuity equation அப்படின்னா என்ன, how the continuity is getting solved here, right? And what is called controlled volume அப்படின்னா என்ன, what is called controlled volume. So based upon the continuity equation, how the next is called as an dynamics of flow, that is dynamics of fluid flow அப்படின்னா என்ன. So in the dynamics of fluid flow, what are the different equations of motions அப்படிங்கிறது let we look upon now. Right. So before going into the kinematics of fluid flow, first let me know what are the different types of fluid flow, right? So there are different types of fluid flow. I just the PPT figure just what is what அப்படிங்கறதா இருக்கும். We just make a note down that there are different types of fluid flow. Say for example, steady flow and unsteady flow, right? So uniform or non-uniform flow, that is laminar and turbulent flow, compressible and incompressible flows, laminar, turbulent, compressible and incompressible, yeah, then uniform and non-uniform, rotational flow and irrotational flow, that is one dimensional flow and two dimensional flow, that is one dimensional, two dimensional, three dimensional flow. So இந்த மாதிரி different types of fluid flows இருக்கு. So say for example, now let me touch upon a steady flow, right? So if it is a steady flow அப்படின்னா the flow in which the velocity of fluid is constant at any point. So ஒரு fluid flow இருக்கிறப்போ if you are saying you are touching at one point, so நீங்க எந்த பாயிண்ட் டச் பண்ணாலுமே, right? So I'm saying இந்த பாயிண்ட்ல இந்த particular பாயிண்ட்ல நீங்க பாத்தீங்கன்னா the having some velocity v1, right? So if this at particular point it is velocity v2, so both the velocities v1 and v2 will be same. So this kind of constant velocity at each point will be same. So that kind of flow is called as a steady flow. It's ரொம்ப important pa. So steady flow, unsteady flow அப்படின்னா the velocity will be different at each individual point, right? Right. So uniform flow அப்படின்னா என்ன, non uniform flow அப்படின்னா, and of course steady flow and an unsteady flow. So steady flow அப்படின்னா என்ன, the pressure will be differ from each to point, but the pressure which does not changes with time. So it is constant throughout the section, throughout the cross sections. So cross section area pressure change agum, but the pressure will not change with respect to time, right? இதே வந்து unsteady flow அப்படின்னா with keep on the pressure will change with respect to time. So for a period of either maybe a seconds, the pressure will keep on changing. So these are the various types of fluid flows. So laminar flow அப்படின்னா என்ன, so it is a smooth parallel line flow without any deviation. So between the laminar flow and turbulent flow, the intermediate flow is called a transition flow, right? So adukku vandu you are having a graph over here that will be seen here. Now is it okay? Are you following me?
Yes sir, following sir.
So shall I continue, pa?
Yes sir, continue. Yes sir.
Right. Right. So when it comes to the point of this laminar flow and turbulent flow, right? So imagine if it is a for let I consider a flat plate. ஒரு flat plate இருக்கு. So if a fluid is flowing over a flat plate, or fluid is flow இருக்கிற அப்படின்னா at initially this is called as an or leading edge ன்னு சொல்லுவாங்க, and this is called as an trailing edge. So these are the two types of edges in a flat plate. So at initially வந்து பாத்தீங்கன்னா the laminar flow develop ஆகும், right? At one particular point of time it will some zigzagness waviness create ஆகும், that is called as an transition zone create ஆகும். So this zone is called as an transition zone. After that it will go for the turbulent boundary layer. So that is another important term. So that is the another important term is called the boundary layer. So in the laminar and turbulent பொறுத்து laminar, turbulent and transition பொறுத்துட்டு they will form certain set of the boundary layer, right? So அப்போ அந்த boundary layer concept வந்து ரொம்ப ரொம்ப important while studying the types of laminar flow, turbulent flow, transition flow பொறுத்தப்போ you must have to study what is called as a boundary layer. Boundary layer அப்படின்னா என்ன, boundary layer separation அப்படின்னா என்ன, right? So இந்த turbulent layer குள்ள below the turbulent that is called as an laminar sublayer சொல்லி சொல்லுவாங்க, that is called as a laminar sublayer. So in the laminar sublayer அப்படின்னா over the surfaces வந்து பாத்தீங்கன்னா the zone is created as turbulent surface create ஆகும், but below the surfaces it will be created as a laminar sublayer. ஒரு turbulent layer குள்ள ஒரு laminar layer create ஆகும், right? So these are the things which is flow over a flat plate normally, right? So now the next one வந்து பாத்தீங்கன்னா as you know compressible or incompressible, right? So normally as I said compressible அப்படின்னா when the density of flow varies with pressure, that is called as incompressible flow, right? So incompressible flow அப்படின்னா density of flow does not changes with pressure, it is called as an incompressible flow. So what does it mean is, so when the density will changes as the pressure changes. So when the pressure increases, as I said the density will get reduces. So yesterday we were saying what is the variation of viscosity related to the temperature number பார்த்தோம். So now, so next important concept வந்து பாத்தீங்கன்னா that is called as a rate of change of flow, that is rate of flow or called as a discharge, right? So so what is called as the discharge அப்படின்னா என்ன, it is the volume of liquid flowing per second. எனக்கு ஒரு if you either going for a pump இருக்கு அப்படின்னா what is the outlet of the pump, the outlet of the pumpல what is the discharge rate or what is called as a rate of flow, அதான் வந்து that is called as an generally we have said it is called as an rate of flow or discharge. So in general the definition will be it is defined as the quantity of fluid flowing per second, this quantity of fluid flowing per second through a section of a pipe or channel. ஒரு pipe or section of channel குள்ள what will be the flowing fluid of per second, that will be considered as a rate of flow or discharge, right? So normally the discharge is Q is equal defined with the term called as a Q. So Q ங்கிறதுனா the respective area into velocity. So this is the general equation of formula for the discharge flow, right? So இப்போ இதுல I want to know what is called controlled volume, right? So for that I just say now imagine we are having a cross section over here. இந்த மாதிரி ஒரு cross section இருக்கு, இந்த மாதிரி cross sectionல I am just consider one particular cross section, right? So இந்த மாதிரி ஒரு individual cross section மட்டும் நான் எடுத்துக்கிறேன் நானு. So இதுல the flow is getting flow in and is getting flow out, right? So with this controlled volume, right? So with the same controlled volume the flow is getting ஒரு inflow மூலமா inflow is happening here, there is ஒரு inlet நடக்குது ஒரு outlet நடக்குது. So என்ன ஆகும் அப்படின்னா இந்த control volume குள்ள there will be no mass losses, that is there is no loss in mass, right? Or there will be no increase in mass or there will be no decrease in mass. So controlled volume குள்ள there will be no increase or decrease in masses within the controlled volume. So அப்படின்னா what does it mean is what is the rate of flow which is at inlet is equal to the rate of flow at the outlet, right? That is A1 V1, right? A1 V1 is equal to A1 V1 is equal to A2 into V2, right? So appo in the cases this is it is consideration of fluid flow in a controlled volume, right? Appo controlled volume la there will be no mass of additional mass எதுமே இருக்காது. So what is the rate of flow in the inlet is equal to rate of flow at the outlet, right? In a controlled volume, right? So upon there will be no adding up of mass abdina, that relates to the concept of the principle of conservation of mass, right? So now what is called conservation of mass, right? So there are three fundamental equations of dynamics that is law of conservation of matter abdina and law of conservation of energy, right? So the energy can neither be created nor be destroyed, that we know very well. If it in terms of consideration of energy again it is states like that the energy can neither be created nor be destroyed, it will be transformed from one state to another state. If in terms of consideration of momentum, right? So everybody will be in a state of rest unless in other ways an external force is getting acted upon, right? Adela, a state that a body in motion cannot gain or lose momentum, right, unless an external application of force is applied. So this is called as a law of conservation of momentum. So based upon this law of conservation of mass, the continuity equation is working on. That is the area at the inlet, that is the rate of fluid at the inlet is equal to the rate of fluid at the outlet, right? That is A1 V1 is equal to A1 V2, but in a controlled volume, right? So that is mass entering per unit time is equal to mass leaving per unit time plus increase of mass in a controlled volume per unit time. But the increase of mass in controlled volume will be zero. There will be no addition of mass. Therefore, mass entering per time is equal to mass leaving per time for a steady state flow, right? So the next one is energy possessed by flowing fluid. Therefore, there are, as we said, there are three different forms of energy. One is called as kinetic energy, and the second is called as potential energy, and the third one is called as pressure energy, right? So what is called kinematic energy? So it is the ability of mass to do work by virtue of its velocity. So the flowing fluid velocity which if the energy is happened, that is called as kinematic energy. Whereas the potential energy abdina, it is respect to the datum level, that is called as pressure energy or potential energy. So P is equal to rho GH, that is denotes it is called as a potential energy, right? And whereas the pressure energy abdina, it is the energy possessed by liquid by virtue of its existing pressure. So based upon the pressure, either through the cross-sectional change, based upon the increase in pressure, the energy which is happened is called as pressure energy, right? So now, based on there are different applications of continuum, that is what we call as mass flow rate. So pipe with the contraction and so there are different applications of this continuity equation. So diffusion and convergence and venturing, probably diffusion and convergence. So pipe which is connected in series and which can connected in parallel. Right. So as I said, there are three different types of energy possessed by a flowing fluid. That is, or flowing fluid la three different types of energies irukum. One is called as kinetic energy, and the second one is called as potential energy, and third one that is called as pressure energy. So the three different types of energies irukku. So in the moon energy relate பண்ணதா பாத்தீங்கன்னா it is called as Bernoulli's theorem. But this Bernoulli's theorem எதில derive பண்ணாங்க அப்படின்னா, that is called as Euler's equations of motion, right? So it is an equations of motion, and என்ன அப்படின்னா the forces due to gravity and pressure are taken into consideration. அதில் வந்துட்டு say for example the water is getting inlet flow, but inlet ஆகிறப்போ there will be a change in pressure. ஒரு particular cross sectionல இருந்துட்டு say for example ஒரு fluid is flowed in a pipe, right? ஒரு cross sectional flow அந்த இடத்துல ஒரு நடக்குது அப்படின்னா, imagine it is a pipe, so இதுல ஒரு flow நடக்குது, right? So what is getting added up here and what is getting flowed up here? இப்போ இந்த particular pointல say for example section 1 and section 2 அப்படின்னா, one particular pointல the pressure is increased to P plus dP, right? So increase in pressure நடக்கும் because of the cross sectional change. So அப்போ this change in pressure மூலமா what we derived is called as an Euler's equation. And the Euler's equation derive பண்ணதான் that is called as an Bernoulli's equation. As you know very well, we have நம்ம கிளாஸஸ்ல வந்து we have solved what is called Euler equation derive பண்ணிருக்கோம் and Bernoulli's equation derive பண்ணிருக்கோம். சரிங்களா? So இப்போ this Bernoulli's equation வந்து பாத்தீங்கன்னா having three different forms of energy. One is potential energy, then second is called kinetic energy, and the third one is called pressure energy. Right? So அப்போ these three energy at inlet, that is at section 1, that is at one section which is equal to at another section. அப்படின்னா என்ன? That is pressure energy, that is P1 by rho g, and the kinematic energy V1 square by 2g, and the datum that is called as Z, potential energy. Right? So V square by V 2g is called as kinetic energy, and P by rho g is called as pressure energy. So sum of these three energies is called as that is at section 1 is equal to section 2. That is principle is called as Bernoulli's equation. So in the Bernoulli's equation வந்து பாத்தீங்கன்னா as you know there are having certain limitations இருக்கு. இத கொஞ்சம் ஞாபகம் வச்சுக்கோங்க. There are some limitations. It is not applicable to ideal interval fluid. So there are different types of limitations இருக்கு. And of course இது வந்து ரொம்ப important assumptions. What are the assumptions of Bernoulli's equation? இது கொஞ்சம் ஞாபகம் வச்சுக்கோங்க. Right? And these are the various applications and assumptions of Bernoulli's equation, but there is some application, assumptions, limitations poga. There are some applications of this Bernoulli's equation, right? So what are those applications of Bernoulli's equation abdina? First one is called as a Venturi meter. Let me move there. Any free slide here? That is called as a Venturi meter is one kind of the application of this Bernoulli's equation, right? Second one then pathina, that is called as an orifice meter. So orifice, and third one then pathina, that is called as an pitot tube. So these are the three different applications of this Bernoulli's equation, right? So next set of applications that is called as momentum equations we have to look upon. So say for example next apart from continuity equation and Bernoulli's equation the next set of equations is called as momentum equation. So momentum equation that is Newton's second law of motion, that is F is equal to ma, right? So the term F is equal to m into a, that is called as a momentum equation. Or this F and the F is equal to, it is acceleration mass into it is rate of change of velocity with time, right? It is and the acceleration எப்படி எழுதலாம் அப்படின்னா it is dv by dt அப்படிங்கிற டைம் எழுதுவோம் நம்ம, right? So it is a dv by dt, or I can say that d of mv by dt அப்படிங்கிற டைம்ல we can able to write, right? So therefore it can be written as f into dt, அதாவது இந்த f இந்த sin change இதுக்கு கொண்டு போறோம். So அப்ப f into dt is equal to d into mv, right? So அப்ப force for a particular instant of time, that is a fraction of time இருந்தது அப்படின்னா ஒரு mass I'm having இருக்கு, say for example it is a mass m. இப்போ இதுல வந்து ஒரு force for a particular f into dt அப்படின்னா என்ன, force ஒரு instant of time, ஒரு fraction of secondல ஒரு mass மேல hit ஆச்சு அப்படின்னா the mass will move with certain velocity, that is m into v அப்படிங்கிற velocityல move ஆகும், right? So this is called as a momentum equation, that is f into dt is equal to d into mv, that is df m into v. So this is called as a momentum equation or momentum principle, right? So இன்னும் so many different applications இருக்கு. So that's all about these application of the fluid flow. So short span of time, let we complete this. Please wait.